Hello, good morning, good evening, good afternoon to everybody. Thank you for joining. Hi, Will. Good morning. Is it still
It
morning
is.
for
It
you?
is.
Yeah,
It is morning where I am. Yeah. Hey, Alex.
good.
Hey, everyone.
Hey, everyone. Thank you for joining. Today we have a special session, so I'm looking forward to that. It's gonna be an interesting topic. I admittedly have not much idea about, but I'm excited. So the topic is improving news recommendations with Cloudflare workers and knowledge graphs. Um, if imagine I don't know what a Cloudflare worker is, could you sum this up in maybe a short little teaser of what's going to happen today?
Yeah, for sure. So, y- you know, part of my job, so I work on the developer relations team, and part of my job is to talk to users and customers and see what technologies they're interested in using with Neo4j. And a lot of times this is different pieces of internet infrastructure, right? So how do we build, deploy our applications? Because Neo4j is really just like one piece of the architecture of larger applications. And Cloudflare Workers is something that's been coming up more and more. I think of Cloudflare Workers as kind of the next evolution of like serverless, or you've heard of like Lambda functions. Basically, Cloudflare Workers are, I think of as like the next generation of serverless
Hmm.
that allows us to really get our content faster, basically.
Okay, cool, very exciting. Yeah, so very interesting. I have a couple of people in chat already shout out. So nice. Thank you for joining, Muntaka in I didn't say where. Good morning, at least. Good morning to you. Good morning to Formación Gráfica. That's a cool name. And no, Muntaka. No, he replied to himself. He's from Nigeria, and it's evening where he's watching. So good evening to you. Um, yeah, I think we're gonna dive right in. You already put the links to the slides or to the deck in chat, so that will be in the description of the video also for later on. Obviously, this video is gonna be available in the future. So if you are watching live but have to drop out at some point, don't worry. This will be available on demand on YouTube. Um, yeah, I hope you keep it lively. Again, we watching chat, so if you have any questions, Will is here. I'm around as well. So we always interested in what you want to learn or what you think about it. So keep it going in chat. But yeah, with that, I think I'm ready to hand it over to you, Will.
Cool, great, let's do it. Yeah, it always amazes me on these kind of streams and presentations to see all the different places in the world that people are joining from. It's super cool. So as Alex said, the link to the slides are on the screen there. Also pasted in the chat, dev.neo4j.com/news-graph. There's links to all the code and examples and things like that in the slides too. So if you're interested in getting that kind of stuff, definitely check out the slides. So what we want to talk about today is improving news recommendations with knowledge graphs and Cloudflare workers. So we're talking about news recommendations. This is like in news apps, like I'm reading the New York Times, Washington Post, whatever. And there's a ton of content out there. Newspapers don't really come in, like the sort of A1s, the most important news, the business section, and so on dead trees that the paper boy throws over the fence. Instead, we have lots of different ways of surfacing relevant content for users. And so that's what we are going to talk about today, specifically looking at how knowledge graphs with Neo4j can improve this process, and then how we can use Cloudflare workers basically to build a news recommendation endpoint. And yeah, as Alex said, if you have any questions or comments, drop those in the chat on whatever platform you're watching on. I'm monitoring them all right here, so definitely let us know. So my name's Will. I work on the developer relations team at Neo4j. Part of my job is to talk to users and customers and see how they're using Neo4j, but really what what technologies they're interested in using with Neo4j. And Cloudflare Workers is one of those that has been coming up more and more. So we're going to take a look at how we can use Cloudflare Workers with Neo4j. The best way to get a hold of me is probably on Twitter. I've got my Twitter handle up there, LionWJ. Also, a link to my blog, where I also publish a newsletter at lionwj.com. If you like podcasts, I also co host the graphstuff.fm podcast, where we talk about building things with graph technology. So if you like that format, definitely check out the graphstuff.fm podcast. So Neo4j is a graph database. I think some folks are familiar with Neo4j. Neo4j, we use a property graph data model, which we'll talk about, and we use a query language called Cypher, which we'll also talk a bit more about today. You can see an example of Cypher in the upper right there. We're sort of drawing these ASCII art representations of a graph pattern, and then it's up to the database to figure out where those patterns exist in the graph. As a database, Neo4j fits in kind of the center of a lot of times the architecture of our applications. So this diagram, I think, does a good job of showing that really there's this spectrum from graph analytics on the right, where we're interested in more data science and analytics type applications, to the left, where we're building applications. We're interested maybe more in how do we build the API layer for my application? How do I support more transactional or operational workloads? So this is a spectrum, and really, I guess what we're talking about today, I think, kind of falls in the middle, right? Because we are going to be talking about some analytics and graph data science, but at the same time, our goal is to build this news recommendation endpoint using Cloudflare Workers. So we're really like sort of talking about how do we operationalize some of the graph data science and graph analytics that we're doing. So let's talk a bit about personalization and recommendations kind of in general, and specifically in the area of news applications. So here's some screenshots from some of the different news apps that I use on my phone, and specifically these are the sort of recommendation piece. So the for you recommendations that are based on either categories that I've explicitly said I'm interested in, or based on my viewing history. These apps know what news articles I've been reading, and are suggesting content to me that I may be interested in based on that history, based on what these apps know about me. And I think that the news area is particularly challenging for personalization. I mean, we see personalization and recommendations everywhere, right? You see this on e-commerce sites. Here are products you may be interested in purchasing, this kind of thing. But I think it's a particular challenge for news applications because there's so much content out there, right? There's so much news going on every day, and our interests as people are really very diverse, right? We're all in different locations, so I care about local news to some degree. Some people are really interested in politics. Some people don't want to hear anything about politics. Some people are really interested in science, right, and so on. And so it's really difficult, I think, to figure out what exactly is a user interested in reading. And this is really, I think, acute for news applications as well because of notifications. So when there's some breaking news event like that's important to us, we want to get that notification, but it's a fine line to balance for the news app, because if they're bombarding us with notifications, then I'm going to turn those off. I'm going to delete the app and not pay attention to it anymore. So it's really this nuanced balance for these news apps to get right. So knowledge graphs can be used for personalization and recommendations. So let's talk a little bit about knowledge graphs. But before we get into knowledge graphs, let's talk a bit about just what is a graph before we get into knowledge graphs. Let's back up a minute. Well, a graph is a data structure made up of nodes. These are the entities in the graph, and relationships connect the nodes. With graph databases like Neo4j, we use a data model called the property graph. So every node has one or more labels. That labels are a way to group nodes. You can think of labels as kind of like a table from the relational model, or kind of like a collection from the document model. Just a way to identify kind of like what is the type of this thing. Relationships have a single type and direction. And then it's called the property graph model because we can store arbitrary key value pair properties on nodes and relationships. So then what's a knowledge graph? Well, a knowledge graph is basically an implementation of a property graph that is, I like to say, putting things in context, and specifically things, because not only do we know the thing is an entity, right? So if we're dealing with news articles, we know that it is an article. We know that the article is about a topic or mentions a person. So we know the type of the thing, and we know some information about the thing, right? We have some properties about the thing. For an article, we might have the title, the URL. For a person, we might have a name and a description of why that person is relevant. For a geo region, it has a name. It also might have a latitude and longitude. So we have some information about the things. And the knowledge graphs put those things in context, so we know how they're connected. So putting them in context, we know the relationships that are connecting these nodes. So I know that this article at the bottom is about the United States economy and US politics. I know other articles that are about these same topics, and so on. In, I think it was 2012, Google released the Google Knowledge Graph API and wrote this blog post, Things Not Strings, that was introducing the concept of the knowledge graph and kind of explaining that when we're searching for things on Google, we're sort of searching for a thing and using the context, traversing the knowledge graph to help boost search results. And that's exactly, I think, the general case of what we're trying to do with knowledge graphs. So I put together this data set that I call the news graph. Basically, what I've done is taken some data from the New York Times API, which releases data. Specifically, what I'm looking at are the most viewed and most shared articles each day. I think we grab 25 from each of those categories each day and store them in Neo4j. And we end up with this data model here. So very much the example from the previous slide was taken from this news graph. You can find the code for this online here in this repo. I'll drop a link to that in the chat. So this data, or this GitHub repo, has the Cypher script for loading this data from the New York Times API. Anyone can register for an API key, and then we're just using APOC load JSON to call out to this API. So if you're familiar with Neo4j and Cypher, you have probably come across APOC at some point. APOC is the standard library for Cypher, which adds some procedures and functions to extend Cypher. And one of those is this function APOC load JSON, which allows us to call out to, in this case, a JSON REST API to fetch. Here we're looking for the most viewed articles of, I think, the last 7 days. And then that JSON object is then able to be referenced in the rest of our Cypher query with this variable value. So I can basically iterate through this array of article results and with Cypher describe the graph pattern that I want to create. So we have data for the imports in this repo and also the code for using with Cloudflare Workers, and then also a couple of examples of how we can build a GraphQL API, both with Next.js and Apollo server here. So if you're interested in this data set, that's the place to go. Let's take a look at some examples. I'm just going to jump into Neo4j instead of look at screenshots here. So here's Neo4j browser. If you haven't seen Neo4j browser before, this is like a query workbench. This is kind of the primary way that we interact with Neo4j as we are developing. We can write Cypher queries and visualize the results. So here we have the basic data model for the news graph. So we have articles. Articles are about a person, topics, geo-regions, organizations like companies, that kind of thing. And then articles have photos. So we can write some Cypher queries here. Here we're looking for the 100 most recent articles. So with Cypher, we define these graph patterns. So this is one of the simplest patterns we can express, which is just a node and its label. So we're saying find nodes with the label article and return those nodes ordered by date published, limit 100. So give me the 100 most recent articles. And let's do a style reset. Sometimes you can see the captions get a bit off, and we can configure the captions that we want this way, or oftentimes just resetting to the defaults works pretty well. Anyway, so here's an article. This is something about TikTok, and we can see the properties that we have stored here. So we have the URL, the title, the date it was published, some description of it. And we can double click to traverse the graph to bring in more nodes. And I can see the topics of this article. So data mining and database marketing. I can double click on that to see other articles that have the same topic and so on. But I can also add more complex graph patterns to my Cypher query. So we have some examples in the history here. So here we're looking for articles, and then we've added a more complex pattern now that says find article nodes and then traverse out to find topic nodes connected to those articles. So I can see here's an article about Sri Lanka, the different topics it has. Here are a couple articles that share topics. So coronavirus, vaccination. So yeah, I've got a lot of COVID related articles in here. And what's nice about Cypher is we can define more complex graph patterns fairly easily using this ASCII art notation. You can see we're sort of drawing with sort of these arrows and circles to represent our nodes. So now we're looking for articles, their topics, and then other articles in those same topics. And here we end up with a lot of coronavirus articles, since that's a popular topic. Cypher is really powerful. We can also do things like say, what's the shortest path between two nodes in the graph? So here we're saying, what is the shortest path from the topic cheese to TikTok? That was kind of a fun one, ends up being pretty short. So there was an article about this cream cheese shortage in New York, apparently, that has the topic quarantine, life, and culture. And then there was also an article about what is this one? This is about TikTok star in Mexico that is about the organization TikTok. So Cypher is really powerful. It gives us a lot of ability to work with graph patterns. And we will see in a minute how we can leverage that to generate personalized recommendations. So I see a question in the chat from Rich. Do you have any property indexes configured in the database? So when we match ordered by date published, does it use the index to produce results? I don't think so. I think I was lazy um, and didn't set up any indexes, but that is a great question. Let's take a look. So here we are matching on all articles, returning the articles ordered by date published, and we return 100. So we can check to see if we're using an index by adding profile to the front of our query. So what profile will do is profile will run the query and then give us the execution plan for the Cypher query. And if we don't want to actually execute the query, we could do an explain instead. So explain is useful if we have a really big query that we don't know how long it's going to take, but we want to see the execution plan. So the execution plan, we write our Cypher query, and Cypher is a declarative language. So we're saying, here's the graph pattern I want you to go find. Database, please figure out how to find this. And the execution engine in Neo4j then generates a query plan that's a series of operations to figure out basically how to find that pattern, how to address basically whatever I've declaratively said in Cypher that I want to accomplish. Now, this is great for if we have a slow query, looking at this metric called DB hits. So basically what we want to do as we're trying to optimize any query or tune any query is get the results that we expect with the minimum number of database hits. And one way we can do that is by using an index to basically very quickly go to the starting point for our traversal instead of sort of scanning through all of the nodes and checking property values or checking checking things like that. And so in this case, we don't have a index on published. We can create one on article published, something like that. So now we've added an index, and let's run our query again. And I think in this case, we end up not using the index either. It's probably because of the size of the data. It's not huge. So I can match on article return count. I think I have maybe like 1,000 or so. Yeah, 4,000. So it's not a huge data set. I don't think I have any indexes in this, but indexes can be useful for finding the starting point of a traversal. Oftentimes, we don't use indexes to traverse the graph, right? So in a graph database, we have index-free adjacency, which means that we're traversing the graph without using an index, but indexes can be important for finding the starting point in that traversal. But yeah, good question. Thanks, Rich. Cool. So that's the data set we're working with. Oh, by the way, so So we saw that Cypher query for calling out to the New York Times API with APOC load JSON to load that in the graph. That works once, but we want this to run like every day, because every day we want to grab the top articles. So I set up a GitHub action to do this. GitHub actions are really cool, just kind of, I don't know how to describe them, like serverless containerized pieces of work that I can sort of define, and they run in the background. Typically, they run in result of some action that I take on GitHub. So when I check code in, for example, we can trigger a CI process to like run the tests in my repo or something like that. But GitHub also has a action that they publish called flat data, which allows us to periodically go out to a endpoint, or also I think we can run a SQL query against a SQL database periodically, and then have some post-processing step. So I set this up. I published a simple GitHub action called flat graph that allows us to just define a Cypher query without kind of setting up all the processing things. So basically, we just define a Cypher query that defines how we want to handle the JSON data that comes back. And that runs this one I think runs once a day because the data is only updated once a day. Question from Mintaka. Cold start is one of the research problems of conventional recommender systems. I want to use Neo4j for this. What's your view on that? Yeah, cold start is something we'll talk about later. So the cold start problem is basically if I don't have any information about users in the network. So when you first sign up for a system or a news application, we don't know anything about you. So how could we possibly give you recommendations? Yeah, so that we have a little bit on that actually that we'll get to later. So yeah, it's very, very relevant question. So we've talked about the data set. We saw how we can query it using Cypher to do things like looking at the topics for articles and this sort of thing. We saw a fun example of using shortest path. But okay, how do we actually use Neo4j and Cypher for personalization and specifically generating recommendations for news articles? Well, there's basically two categories of approaches to recommendations with graphs. There's collaborative filtering and content-based filtering. So collaborative filtering, we are using the preferences, ratings, actions of other users in the graph, in the network, to find items to recommend to a user. So this is the kind of thing that if I have rated a bunch of movies, I can look at other users that have rated similar movies that I have. What other movies are they rating positively that I haven't seen? Those are good candidates for recommending to me. Or with products, I've bought this pair of shoes. Look at all the other users that bought the same pair of shoes. What are something else that they bought that I haven't? That might be a good recommendation. So, kind of wisdom of crowds using data about users in the network to generate recommendations. Then the other approach is content-based filtering. So where I'm recommending items that may be similar to an item that I have expressed interest in. So if I'm watching a movie and I like this movie, we could look at what are other movies that have the same actors or the same director or maybe the same genres, this sort of thing. But in both of these, we're traversing the graph to find relevant recommendations. So if we look at collaborative filtering, the first step is basically to find similar users in the network. So we can think of this as like my peer group or my cluster, my community in the graph. And then the next step is to identify what actions those users have taken that I haven't taken yet. So what products have they bought that I haven't purchased? What movies have they watched that I haven't? Or in the case of our news graph, what news articles are they reading and sharing that I haven't yet. So one way to approach this, there's lots of ways to approach this. One way is to use similarity algorithms to find the most similar users in the network to handle that first step. Another one would be clustering or community detection algorithms. So a popular one where we have ratings is cosine similarity. So I'm basically taking two vectors where the vector is my rating of items. So the example on the screen there comes from the recommendations Neo4j sandbox, which is looking at movie ratings. So I have a vector of all of my ratings of movies and compare that to the vector of other user ratings, calculate a cosine distance between the two users based on those two vectors of ratings. Gives me a value between 0 and 1 of how similar two users are. Do that for all users in the network, and I can see who has the most similar sort of taste as me. Oftentimes, though, what's interesting about ratings, and I think especially maybe like movie ratings, is that people have a different baseline. So for some users, a 4 is really, really good for them, and they'll maybe never give out a 5 or very rarely give out a 5. Whereas other users, if something is, yeah, that was good, I'll give it a 5. So everyone has sort of a different baseline. Pearson similarity takes that into account. It's basically calculating a correlation coefficient, but it's basically looking at variation about the mean rating. So that can be a good one to look at as well. All of these similarity metrics that we're looking at are available in the Neo4j Graph Data Science library. So you can see the Cypher examples there. We're using calls to the GDS library. And again, all the examples come from the recommendations Neo4j sandbox. But there's a problem with collaborative filtering. And this is exactly the problem that Muntaka brought up in the chat, this idea of a cold start problem. So here's one of my news apps that I wasn't signed in or something, and I opened it up to take a look at my personalized recommendations, and it basically says, hey, I don't know anything about you because you're not signed in. I can't give you any recommendations because I don't know anything about you. I don't know anything about your preferences. And this is really a problem because we really want to be able to generate recommendations for users as quickly as possible to help drive engagement with our application. So once I did sign in, then okay, we know your interests based on other articles you've read and so on, so we can generate some recommendations. So what is one way we can avoid this cold start problem? Well, and one way to avoid that is this idea of content-based recommendations. So here's an example from this comes from the New York Times article. So this is an article looking at a railroad in Bulgaria. And at the end of the article, I have other recommendations for, in this case, things like other travel articles, other articles about Bulgaria, this sort of thing. And if we look at that, so I found that article in our news graph. And if we look it up by title, well, one way we could generate content-based recommendations is look at overlapping topics. So what are other articles that share topics or other articles that are about the same geo-region, which in this case is Bulgaria. So we can see how we can traverse the graph that way to generate personalized recommendations. Okay, so we've talked a little bit about how we can use knowledge graphs in Neo4j for generating personalized recommendations for news articles. How do we operationalize this? How do we actually build a personalized recommendation news endpoint? And this is where Cloudflare Workers comes in. So Cloudflare Workers, I think, are really uniquely suited for this type of personalization. Cloudflare Workers are, I think of as kind of like the next evolution of serverless. So if you're familiar with things like Lambda functions, you're deploying these serverless functions to a specific region. So I'm deploying my Lambda to US East 1, and it sits in a data center somewhere in Virginia. So anytime I'm calling this endpoint now for my Lambda function, even if I'm on the other side of the world, it's going to a server sitting in Virginia. Yesterday, we saw US East 1 go down, so lots of services. So not only is that kind of slow because of the network, but it's not very redundant, right? And there are ways to deploy your serverless functions to multiple regions. So AWS has a service called Lambda at Edge, which basically allows you to deploy to multiple regions. But Cloudflare Workers is really an evolution beyond that sort of idea of a Lambda function, a serverless function, where we're actually running code on the content distribution network. So CDNs are much more prevalent than regions. So they typically live in cities instead of regions of the world. So what this means is that when I go to view a web page and I'm loading static content like HTML or image files, we don't want to incur a lot of network latency by, say, a user in, I don't know, South America that has to go all the way to Virginia to incur the network latency to send that. Instead, we want to go to a CDN node somewhere in South America in that user's country, ideally in that user's city, right? So this is kind of a solved problem for static content. We know how to do that by deploying to a content distribution network. And edge handlers, Cloudflare workers, these sorts of things are actually running code now on those CDN nodes, on the machines deployed all throughout cities all over the world, much more widely than just regions. We're actually running that, and there's a different architecture with Cloudflare workers. So overhead is really sort of reduced per instance, and really the benefits that we see with Cloudflare workers for personalization are that all these workers are geolocation aware, right? So we know not only what city the user's request is coming from, but oftentimes Cloudflare has some services for adding things like the latitude and longitude of not just where the CDN node is, but where the user's request originated from. Adding services like bot detection and caching and these sorts of things can be really helpful with Cloudflare workers. So I'm pretty excited about Cloudflare workers. I think it's really neat. There are other similar things like edge handlers. I think on Netlify are a similar idea. And then there are services built on top of this. So like Vercel has now edge functions, I think they call them, which is built on top of Cloudflare workers. Okay, so let's look at an example. So this is a simple architecture diagram of what we want to build here. So I want to have a news app that can go to my endpoint served by Cloudflare workers, and then my worker is going to go to Neo4j to basically generate the personalized recommendation for the user. Cloudflare workers have a CLI called Wrangler that is a good way for getting started. There's also a web interface, but I like Wrangler so we can develop and test and deploy locally. So we install the Wrangler CLI tool, and then we can generate from template projects. So there's an example that Cloudflare has published using I think it's called the IDI router. It's like a very simple router that allows us to have different endpoints, different routes on an endpoint. So I started from that template, and then we also want to save our connection credentials for Neo4j as secrets, which we can do with Wrangler, which is nice. And then that's available as environment variables locally and also when we go to deploy it. Here's the example. Let's instead of looking at screenshots, let's jump into VS Code. You'll have to excuse my color theme. I'm in the holiday mood. This is which one is this? I think this is called North Pole. So very very Christmassy. Yeah, North Pole. There's also Santa Baby. Maybe that one's a little more readable. Okay, let's zoom in a bit. That's too big. Yeah, maybe that's good. So this is the code for my Cloudflare worker endpoint. This is JavaScript. Um, so we can see this is the router that the template project was pulling in called itty router. And then I wrote a function here that is basically just a helper for sending a HTTP request to Neo4j. So one thing to be aware of with Cloudflare workers, because of the architecture, some of the networking issues are handled a bit differently with workers. So, for example, opening an arbitrary TCP connection from a worker right now is um, does not always work in some cases. I know Cloudflare is working on this. They actually just a couple of weeks ago released kind of a proxy thing that proxies TCP over WebSocket, I think, for helping with these kind of database connections. Fortunately, with Neo4j, we don't need to worry about TCP. So if we were using Bolt, which is the primary way that we interact with Neo4j drivers, that's a binary protocol over TCP, then we would have to think about how we can proxy that to our worker. But Neo4j also supports HTTP requests, so we can send Cypher requests to Neo4j just over an HTTP connection, which is perfectly fine from a worker. We can open HTTP requests from inside a worker just fine. So we're using the HTTP endpoint for Neo4j instead of the Bolt endpoint. So something to be aware of for working with databases in a worker. But again, I know this is evolving quickly. This is something that Cloudflare, I think, has on their radar. Anyway, so this is just a helper function for adding the headers for that HTTP request to the database and then structuring the database given our Cypher statement and any Cypher parameters. So then here's our first route. So for the index route, we get past a request object. And the first thing we want to do is figure out the location of the user. So for this route, what I want to do is take the user's location into account and figure out, okay, where is this user? And then I want to find basically what are news articles about the region most closest to the user. So what we do is we get the latitude and longitude of where this request originated. So where is the user located? And then in our Cypher statement, we're going to find any geo regions that are closest to this point. So it finds the 10 closest geo regions that we have in the database. And then we traverse the graph to find articles that are connected to those regions. And then we're returning the article information. And then we also traverse out to find what are the other geos and topics and organizations connected to this article. If you're familiar with Cypher and this looks a little funky, this is using a map projection and pattern comprehension features of Cypher to basically return a JSON object. So this is a pattern that I really like to use when I'm creating endpoints like this that's just returning some JSON object. I can actually pretty much construct that JSON object with a map projection combined with pattern comprehension in Cypher, which I think is quite tidy for creating these kind of endpoints that are returning JSON. We then pass that Cypher request to Neo4j, passing in user's location as a parameter. And then because we're basically returning a JSON object from that Cypher query, we just have to grab it out of the first row and return that. result. So let's do a Wrangler, the Wrangler dev, I think, to start a local server with this. And it says running locally on port 8787. So let's check that out. Localhost 8787. So we should be seeing local news. So I live in Montana, and the first article I get is an article written by the former governor of Montana about, I don't know, something about politics. But you can see one of the geos, Montana. So, yep, that one looks good. Next article is about some murder in Spokane. Spokane, yeah, that's like a couple hour drive from where I live. Articles about Idaho, which is just maybe an hour's drive from where I live. So the next state over, and other articles about Montana and Farm Aid and these sorts of things. So okay, this is pretty good. These are relevant articles based for me based on my location, so giving me kind of local news. That's nice. The next thing we want to do though is, so I'm reading an article and uh, I want to see other similar articles based on content. So I'm done reading. Maybe I read this article about uh, rural politics, I guess is what this is getting at, and how Democrats can appeal more to rural areas, I guess. And if that's something I'm interested in, I want to read more articles about that. How would I use the ideas that we talked about of content-based recommendations to recommend articles? So for that, we created a second endpoint. I see a question in the chat from Chris. He says, "What app is that?" Are you asking about what is the Chrome extension that's rendering sort of pretty print JSON? So I'm just opening. Basically, I'm just opening this localhost 8787 endpoint in Chrome. I don't know what it's called. I think if you search Chrome extensions, it's something pretty print JSON. There's a few of them, but basically, it's nice if you load JSON in Chrome. It gives you kind of a nice pretty print. Then you can also just kind of collapse arrays and things like that. Yeah, I think it's called pretty print JSON. But if you search the Chrome store for JSON, you'll see a bunch of them. So that's our first endpoint. We created then another endpoint. So now if we go /recommended and then / the ID of the article, now our Cypher query is going to look up that article by ID, and then we're going to search for, okay, what are all of the topics, geo-regions, organizations, and people that this article is connected to, and then we're going to use Jacquard similarity from the GDS Graph Data Science library to find the most similar articles. Jacquard similarity is basically a set comparison operation. Earlier we were looking at like cosine distance and Pearson similarity. And in those cases, we had ratings. We had numeric values to compute a distance. With things like Jacquard, it's binary. Either this is about this topic or it's not, right? There's no like rating associated with that. So Jacquard allows us basically just to compare two sets for sort of existence, like is this thing in this set, and calculate a similarity score based on that. So we find 10 articles that have the highest Jacquard similarity, and then again we use this map projection and pattern comprehension to return basically a JSON object, so an array of recommended articles based on the ID of whatever article we've passed in the route. So let's look at that one. So we'll just grab this article about politics in Montana. We'll grab its ID and we'll go to /recommended /16424 is the ID for that. And so now we should see articles that are similar to this article that was about rural politics in Montana. And what do we get? We get something about the Democratic Party and its decay, state legislatures, midterm elections. All these kind of have the Democratic Party in common. Rich is back with another question. Is using internal ID risky given IDs can be used by the database? Yes, it is. Rich, you are doing a great job of pointing out my laziness of not creating indexes and using the internal ID. Yeah, so this is a really good point though. So this ID is the internal node ID of the node. And so in Neo4j, every node and relationship has a internal ID, which is a value that basically points to an offset on disk. And this is earlier we talked about this idea of index-free adjacency and how in Neo4j we're able to traverse the graph without using an index, basically just a constant time operation to do this traversal. And that's facilitated by this idea of offsets in the file store. So an ID is pointing to an offset in the file store, so like a physical location in the file store. And when I delete nodes and then load data again, those IDs can be reclaimed, right? So if I have an ID that is this block in the file store, if I delete it, well, then I want to reclaim that space in the file store, and I might load another ID, load another node into this space in the file store. So it's generally not a good idea to use internal node IDs in external systems because they can be reclaimed. Um, so I did this again because I'm lazy. We in this data set we didn't have a unique ID for these articles. I suppose I could use the URL. That probably would be good. But in a lot of systems, you have like a UUID or something to identify a node's uniqueness. So I was lazy and kind of just went with the internal ID. It's fine in this case because yeah, as you say, like I'm not deleting data. I'm only adding data to this data set. So I think in this case, these internal IDs are going to be stable. But yeah, just it is just a general best practice not to use internal node IDs referenced in external systems. And also, it sort of only lives um, for the result of this query. So in this case, I think it's okay. But yeah, it would be better to use a UUID if I had it, or in this case, probably the URL of the article is probably safe to use. I'm assuming those article URLs are not repeated. But yeah, great point. Okay, so that's our second endpoint. So we can now get local news based on a location, and then when I'm done reading an article, I can find similar articles using Jacquard similarity. So we've been running this locally. Let's give this a deploy. So Wrangler publish will now deploy this all throughout Cloudflare's CDN, and it gives me this endpoint now. So this is news.graphstuff.workers.dev. I'm going to paste that in the chat. And so you should be able to hit that endpoint. You can just open it in your browser like I have. And what you should see are articles that have something to do with locations closest to you. And all this comes from the New York Times. So there should be pretty good coverage throughout the world, I would think. So I'm curious how well this works for folks if you wanna try that and see what kind of articles you get recommended if it actually does take your location into account. So let us know in the chat if you see anything interesting there. So now we've deployed our endpoint. We're now using Cloudflare's CDN to to sort of execute our custom code. So when you hit this endpoint, that code is running on the CDN node closest to you in your city. It's not going to a region in the in a data center. Rich asks, where do secrets come from? Are you accessing it through environment variables? Yeah. So Wrangler allows us to set secrets in the CLI. So I used like Wrangler secret put Neo4j URI, something like that, and then it asks me what value do I want for that. And it is, I guess it's not quite an environment variable because this is sort of a custom runtime. They're basically just global variables that get set in the worker environment. So in my case, I've set Neo4j auth, which is a basic auth header because we're using the HTTP request to Neo4j, and then also the Neo4j URI somewhere down here. Yeah, this one. Yeah, so it's like an environment variable, but in our code, it's basically a global variable, and the Wrangler CLI handles that both for local development and then also for deployment. We can set like local and production values differently. I just set the same one because I only have the one Neo4j instance. Cool. So I think that is about all that I wanted to show. Hopefully that does a good idea of sort of motivating why you would use knowledge graphs in Neo4j for recommendations and how you can use Cloudflare Workers alongside that to sort of operationalize some of the ideas that we have available in Neo4j. So all the code for everything that I talked about is on GitHub, linked there in this news graph repo. I'll drop a link to that in the chat as well. And I said also there's some other examples in here for working with GraphQL as well. So I'll end with just a couple of resources that you may find useful. I mentioned Neo4j Sandbox earlier, specifically the recommendations sandbox, where we were looking at calculating those user similarities using the GDS library. The recommendations sandbox instance has data from the Open Movie data set, and Movie Lens is where the ratings come from. So those are combined together. And then we see how to generate personalized recommendations using a few different approaches. Sandbox is nice because I can spin that up. I get an instance that's private to me, along with some guided queries that kind of walk me through that in Cypher. So a great way to learn some of the more advanced things we can do in Cypher. And then we didn't use this explicitly, but this is a good tool in general that I want to make sure everyone's aware of, which is arrows.app. So this is a graph data diagramming tool, I guess, that allows us to create our graph models. So anytime you see some of the graph model diagrams, those are typically created with arrows. And this is also useful because we can export the JSON to create those and check that into version control. So I can check my model into version control, have others work on it as well. Great. So that's it from me. You can check out my Twitter and personal blog and newsletter there as well. And then, as I mentioned earlier, I also host the graphstuff.fm podcast. So definitely check that out if you are into podcasts. And that's it. So thanks very much for joining today.
Cool. Thanks, Will. Thank you all for joining. Indeed, thank you for presenting, Will. was very interesting, and I think it's a good start. So, like you said, if anybody wants to try this themselves, then I think you provided all the material, and then if you have any questions further on, or if you're stuck with anything, we have a community forum or a Discord server where you can definitely go and ask your questions, and we will surely have eyes on these two channels, as well as obviously others. But that could be a segue. Yeah, with that, I think we're done for today. Thank you all for joining. Thank you for an interesting chat conversation today. So that was nice. I think next is Monday. Actually, Michael and we will talk about Aura Free and a couple of interesting data sets, how to get going with that.
Do you
So
know what data set you're going to use yet for Monday?
no, not yet. No, I think
It's
we're
always a bit of
gonna.
a surprise, right?
It's always gonna be a surprise, yeah. But I have a gut feeling that with Michael's Pandora paper blog article from earlier today, or actually yesterday, I am pretty confident that we might look into that data set, um, because it just makes sense, and then we just posted about it. I think it's in the developer blog, so it's not
Ah,
on the regular one. So if you type in
but just
develop,
blog/developer? Yeah.
no, slash developer hyphen blog, I think that's what it
Ah,
is.
yeah.
Yeah, here we go.
Yeah.
This is it. So I guess we do that on Monday. But if you wanna be eager, you can always read the article from Michael already.
Cool. I'll link that in the chat in case anyone's interested.
Exactly. Cool. Thanks, Will. So yeah, have a look at that. Have a look at the material from Will. Again, thank you for showing us through this. This was really insightful and interesting. Let us know if you program your own news recommendation app. It's no shame to brag if you have done that. So if should you do this over Christmas or the holiday season, then post it in on Twitter and let us know.
For sure.
Yeah. All right. With that, thank you all for watching. See you soon. And yeah, take care, everybody. Bye.
Bye-bye.